Sample test number 2. Okay, determine P of 5. That would be putting 5 in for T here, and that would be 3,000 times 1.052 to the 0.2 times 5. Simply just plugging it in. So if I go to my calculator and make this easy on myself, I'm probably going to use this equation several times. So I'm going to type the equation in, which I've already done, and then I'm going to go to second table, and I'm going to put 5 in, and it tells me this comes out to be 3156. And it says, and tell what this value means in terms of the context. Means that 5 years after 2000, so in 2005, the population was, or will be, was 3156. B, determine the rate of change at 30. So P prime of 30 would be the limit as h approaches 0 of P with 30 plus h in it, so that's 3,000 times 1.052 to the 0.2 times 30 plus h minus 3,000 times 1.052 to the 0.2 times 30 over h. And to come up with this is not something we know how to take the limit or do algebraically. So we're going to go to our calculator and get it to do this calculation for us. And I'm going to do this the simple way, so I don't have to type all this in. This is just the equation I had before with 30 plus h in it, and then the equation I had before with 30 in it. And I can do that by typing in this. Let me just type it. So I'm going to turn this equation off by pressing enter on the equal sign. Come down and turn this one on, and I'm going to go clear it. And now I want to do a numerator, so I'm going to put parentheses. And I want to plug 30 plus h in for the x of that one. So I'm just going to go y bars function y1, this equation, using for the x 30 plus, not h, but x, close parenthesis. So that's a short way of typing all that in. Minus, and then I'm going to do y1 again of just 30. So that's the numerator, and that's all divided by x. And so there's this whole thing typed in, and now I just want to find the limit of it by letting h get close to 0, or in this case, x get close to 0. So I'm going to go to my table, and I'm going to put in 0.1, hitting that minus, 0.01, 0.001, 0.0001. Okay? And then I'm going to get close to it from the other side, so negative 0.1, negative 0.01, negative 0.001. And it looks like this limit is approximately 41.23. And what is it telling me? Write a sentence that explains what the meaning of this. This means that the population is growing at a rate of 41.23 people per year. Now that's an average, and 41 would be good enough. I can't get fraction of people, but roughly 41 and a quarter new people per year. In the year 30 beyond 2000 is 2030. I probably should put that on there. Okay. Determine p double prime at 30, whether it's positive or negative. Well, I'm just going to do it simply here. This is an exponential, and we know exponentials like this, and therefore an exponential, this exponential curves up, meaning population is increasing. So since it curves up, the second derivative has to be greater than 0, positive. Because the second derivative is a measure of curvature. And finally, determine the equation of the tangent line at P at t equal 30. So let's just do the linear approximation. So the linear approximation at the point we're concerned about is 30. And this is at t, so I'll put t here instead of x, but x would be fine. It's going to be f prime, which p prime at 30, which we decided was 41.23, times t minus 30 plus p at 30. And so I need to find p at 30. So I'm going to go to my calculator again and just type in. So this is the difference one. I'm going to go back and put it into y1. So I'm going to turn it back on. If I go to the table, now I'll see y1 and y2. This is what I want, and I want it at 30, and it's 4066.5. And that's people. This is the size of the population, a linear approximation for the size of the population at p equals 30. Equation of the tangent